Hi class. So last time we learned about a sum and different formulas and also their applications to establish more identities and to handle with unknown angles or tricks inverse function. So before we start the lesson for today, I would like to review the formulas of the sum and different angles. So for psi, we're gonna have psi of a plus b equals to psi of a times cosine of b plus cosine of a times psi of b, and similarly for minus, in between we're going to have a minus sign. Okay, and for cosine of a plus b, we're going to end up having the difference, so it goes like cos a cos b minus psi a psi b. And when it comes to cosine of a minus b, it's going to be cos a cos b plus psi a psi b. So for sine, the operation doesn't change, but for cosine, the operation it changes. So for sine, if you have a sum, you stay with a sum. If you have a difference, you stay with a difference. While for cosine, if you start with a sum, you end up with a difference, and you start with a difference, you turn out to be end up with a sum. Okay. And also keep in mind that we learned about the Pythagorean identities. We have three of them. The first one, it goes like cosine squared plus psi squared equals to 1. And then we also have tangent square of theta of x plus 1 equals to secant square of x. And the last one is similar to the second one. It goes like cotangent square plus 1 equals to cosecant square. Okay, and we also learn about the quadrant of the inverse trig functions. So you guys usually see me in class drawing the unit circle like this. And then I'm going to tell you guys that we never ever will use quadrant 3. So let me cross it out really quick in here like that. And then for quadrant 1 and quadrant 4, we have sine inverse. We have the reciprocal of psi, which is cosecant inverse. And we also have tangent inverse. Okay, so the quick way to remember this one is that think about it, all students take calculus. So in question 4, calculus means cosine must be positive, right? But for inverse function between question 1 and question 4 right here, question 1 will take the positive value and question 4 will take the negative value. So on question 4, cosine cannot be negative because it's already be positive according to the all student take calculus, right? So that means cosine inverse cannot be on this list. That means you only have sine inverse. Okay, and then the reciprocal of sine would be cosecant, and tangent would be in there also because of the quotient identity. We know that tangent equals to sine divided by cosine. So we will base it on the top of the fraction. So tangent would go together with sine. Okay, with the same logic, we will have quadrant 1 and quadrant 2 for cosine inverse and the reciprocal of cosine, which is secant inverse, and also cotangent inverse. So again, quadrant 1 would represent the positive values and quadrant 2 would represent the negative value. And according to the all student take calculus, quadrant 2 is student, meaning psi. Psi must be positive in here, right? So that's why psi is not on the list of the yellow marks in here. So that means cosine inverse has to be in there, and the reciprocal of cosine would be secant. And according to quotient rule, cotangent equals to cosine divided by sine. That's why cotangent will go along with cosine here. Okay. And just really quick about the all student tech calculus. So I told you guys that this chart in here is only for inverse function. That's why we have the symbol of -1 on each of the 6 functions in here, because they are inverse trig function. While on the all student tech calculus, the other chart, all student tech calculus, this one in here is only for regular trig function. What do I mean by that? I mean like sine, cosine here, tangent, and then we also have cosecant, secant, and cotangent. So make sure you don't get confused between when to use which diagram in here, okay? So that's it for the review, and now let's move to the second page. So before we get to the formula of today, because you guys have to memorize, just like how you guys have to memorize all the identities on the finals and on the quizzes, I would like to introduce you guys some like tips, some derivation to help you guys understand at least how the formulas come from, so that you can like have some sense how to find it, how to reproduce it, just in case you guys don't want to memorize it. Okay. So The topic of today is about the double angle and half angle formulas. So to start with it, let's talk about the double angle. Double means two. So we want to figure out a formula for psi of 2 theta, cosine of 2 theta, and at the end, we also want to know the formula of tangent of 2 theta. Okay, so let's begin with psi of 2 theta. So we know that 2 is 1 plus 1, right? That's like common base. Okay, so we're going to start up with the idea that 2 theta equals to theta plus theta on the inside of the trig function. Okay, and then since we know the sum formula, psi of a plus b equals to psi of a cosine of b plus cos of a psi of b. Unfortunately, in here, we have theta in place of a and b, so technically we don't have to worry about which one is a and which one is b because they all are theta. Okay, at the end, psi and cos is the same thing as cos and psi because multiplication doesn't matter the order. So then we can combine the like term and we have 2 psi theta, cosine theta like this. Okay, so this is the first formula that I want you guys to remember. Similarly, we also wonder what happens to cosine of 2 theta. So with the same logic, we first split 2 theta into theta plus theta. And after that, since we know the sum formula for cosine, it goes like cos A, cos B minus psi A, psi B, right? And fortunately, in here, A and B are both theta, so we don't even have to worry which one is A or which one is B because they are all theta again. And for the first group, we have cos A, or like cos theta times cos theta, which is cosine squared theta. For the second group, with the same logic, psi theta times psi theta, we have psi squared theta, and in between, we have a difference. So keep in mind that I told you guys before, for cosine, we start with a sum, we're going to end up with a difference. Okay, so make sure you don't mix it up on the test or on the quizzes, okay? So this is the second formula that I want you guys to remember. Cosine of 2 theta equals to cos squared theta minus psi squared theta. Okay. So the interesting thing about this formula is that it has a square, right? So whenever you see the square, it reminds us of the Pythagorean identities. You guys see how we can manipulate around the cosine square like psi square in the quizzes previously. So we're going to do the same thing over here. So in the formula we have right now, we have cosine of 2 theta equal to cos squared theta minus psi squared theta, right? So we have both cosine and sine in this formula. So what if you don't want to have cosine in that formula? What if we want to solve for cosine of 2 theta in terms of sine only? Then what do? We need to get rid of cosine squared theta, right? How can we get rid of cosine squared theta? We're going to solve for cosine squared theta right here. So cosine squared theta equals to 1 minus psi squared theta. We're going to substitute it in here in spot of cosine squared theta. Okay, and we're going to rewrite the formula, like a part of the formula. So we're going to rewrite minus psi squared over here. So now we end up having 1 minus psi squared theta minus psi squared theta. And then we come by the like terms. We have 2 psi square theta in here. So at the end, we have the formula cosine 2 theta. And I'm so sorry for my bad writing. So technically, this is cosine 2 theta equals to 1 minus 2 psi squared theta. And in here, if you want to solve for psi squared of theta, first of all, we're going to have to get rid of 1 by minus 1 from both sides. And after that, we would have to divide both sides by -2. And then we have the formula right here. Okay. With the same logic, what if we don't want to have sine in this formula right here? What do? We would need to solve for cosine of 2 theta in terms of cosine. That means wherever we see sine, we have to get rid of it. How can we get rid of it? We have to get back to the Pythagorean identities right here. We know that minus psi squared equals to cosine squared minus 1 right here. So then we substitute it back in, and then we rewrite cosine squared in here. So now we end up having cos squared theta plus cos squared theta minus 1. And then we come by the like term, and we end up having 2 cosine squared theta minus 1. And this is also the formula for cosine of 2 theta. So in short, we have 3 formulas for cosine of 2 theta in here. The first formula is cos squared minus psi squared. The second formula is 1 minus 2 psi squared. And the last formula would be 2 cos squared minus 1. I would expect you guys to remember all of them because they all three of them are really useful. You guys will see why in a minute. Especially when you try to establish the identities, they are super useful. And the next question you guys want to ask me is that since we have 3 formulas, so how do we know which one to use at which time? And then I'm gonna tell you it really depends on the question. Okay, so if you guys see all sides in your equation, you're gonna have to go with this formula: 1 minus 2 psi squared theta. If you see only psi, or like if you see only cosine in your equation, you will have to go with this formula in here because it has 2 cosine squared theta minus 1. And if you see a mixture of cosine and sine, you want to use this one because it has a mixture of cosine and sine. Okay, so it really depends on the question. The more practice you get, you're gonna get used to it. Okay. And in here, if we want, we can solve for cosine squared theta. So we're going to do the same thing using PEMDAS. So first of all, we're going to move away the -1 by adding both sides with 1. And after that, we divide both sides by 2. And we're going to get cosine squared theta equals to 1 plus cosine of 2 theta all divided by 2. Okay. So for now, just a recap, we having psi squared of theta equals to 1 minus cosine of 2 theta divided by 2, and cosine squared of theta equals to 1 plus cosine of 2 theta divided by 2. So what if we want to solve for tangent squared of theta? We know that tangent equals to sine divided by cosine by quotient rule. So keep that in mind. And now it has a square. So that means we're going to do sine squared of theta, which is the top part, divided by cosine squared of theta, which is the bottom part. So I'm just going to substitute sine squared of theta for 1 minus cosine of 2 theta divided by 2 on top. And I will go ahead and substitute 1 plus cosine of 2 theta divided by 2 in place of cosine square on the bottom. Okay, and then we're going to do keep flip multiply. That means we're going to keep the first fraction. We flip the second fraction. We multiply them. After that, we will cancel the 2's. So then we're going to end up having 1 minus cosine of 2 theta on top and 1 plus cosine of 2 theta on the bottom. Again, I would not expect you guys to remember all the derivation. I don't want you guys to like squeeze your memory to remember all of these, but at least remember the formula in the boxes, okay? So make sure you know them all, okay? And the next bullet point, if we multiply the fraction that we currently have by the conjugate of the denominator, we will end up having something else. And we do the same thing, but this one, we're going to multiply by the conjugate of the numerator, which is the top, and then we're getting something else also. So for this formula right here and this formula right here, you guys will not have it on a test, so don't even try to memorize it. It's just going to be for fun, okay? So this is just for fun. Don't memorize them. I mean, if you want, you can memorize them, but I'm not going to like try to like ask you on the test for these questions, for these formulas, because personally, I think they might be too hard for you guys to memorize. Okay? And then comes the last bullet point. So we wonder what happened to tangent of 2 theta. With the same logic, we're going to go ahead and split out 2 theta into theta plus theta. Okay, and then after that, we apply the sum for tangent in here. And for tangent, keep in mind that, first of all, we're going to distribute the trig function-ish. So then we end up having tangent theta plus tangent theta on the top part. And for the bottom part, you have to remember there's a 1 in the formula. And if you start with the sum, you have to end up with a difference. And if you start with a difference, and here's going to be a sum. Okay, and then we put the 2 tangents together. And at the end, we come by the like term. So on the top, tangent theta plus tangent theta, we have 2 tangent theta. On the bottom, tangent theta times tangent theta, we're going to have tangent theta squared, or tangent square of theta. So what you guys need to memorize from this? First of all, you need to remember that sine of 2 theta equals to 2 sine theta cosine theta. Second of all, you need to memorize the 3 formulas of cosine 2 theta. The first one is cosine squared theta minus sine squared theta. The second one is 1 minus 2 sine squared theta. And the last one is 2 cos squared theta minus 1. In my opinion, as long as you remember the first formula, which is this one right here, the other two, this one and this one, you can derive them. It's not going to be that difficult, especially you learn how to manipulate the Pythagorean identities already. So don't waste your time memorizing all three of them. You actually just want to memorize this one, okay? And the last formula that I want you guys to memorize is this one. Tangent 2 theta equals to 2 tangent of theta all divided by 1 minus tangent squared theta. So make sure you guys at least memorizing this, this, and this. Okay. As for the two circles in yellow, it's just for fun. Okay. So if you guys can memorize it, but don't try it. Okay. And for the outer boxes, for this formula in here, this formula in here, and this formula in here, if you want, you guys can memorize it. But like I said, you guys can derive it. So don't waste your memories on these. Okay. So now let's put everything together on the next page. So for sine and cosine, again, sine of 2 theta equals to 2 sine theta cosine theta. And then for cosine of 2 theta, we have three formulas. The first one, it goes like cos squared minus sine squared. Second one, coming from the first one also, it is 2 cos squared minus 1. And the last one also comes from the first formula. It is 1 minus 2 sine squared theta. Okay? So again, I'm going to give you some tips based on my own experience for these type of problems. So before we even get into the problems, so whenever you solve for a value, make sure you also have to pay attention to the sign, right? You guys see how the sign matters in the quizzes and the exams already. So just because you guys have the same angle, for example, like when we talk about reference angle, the side matters. It matters a lot, okay? So you have to depend on what quadrant your angle lies in to decide whether it's positive or negative. Don't just blindly assume that it's always positive all the time, okay? So let's do the first example. Given that theta is in between 0 and 360, find the value of sine of 2 theta. Okay, so now we have to find the value of sine 2 theta. And just really quick, sine of 2 theta, it equals to 2 sine theta cosine theta. So we're going to go ahead and use this formula. If we want to solve for sine of 2 theta, we have to know the value of sine theta and also the value of cosine theta. After that, we're going to multiply them together. We multiply by 2, and then we call it an answer. Okay? So let's talk about a problem. The first example, I give you guys secant of theta equals to 2, and we know that cosecant is also negative. Okay? So first of all, let's draw it out. Let's see what quadrant it's in. So we have all students take calculus, right? So secant in here is positive. So that means that we will have either quadrant 1 or quadrant 4 if I'm not wrong, right? Because all students take calculus. The last one is for cosine. Cosine, the reciprocal of it would be sine. So we only have secant positive in the first quadrant or in the fourth quadrant. Okay? And also cosecant is negative, so it's definitely not quadrant 1, right? So we're talking about quadrant 4. So let's make a random point here, any point that you want to. Make a right triangle, and then make your angle theta toward the origin, like this. Secant is the reciprocal of cosine. Cosine is opposite. No, cosine is actually adjacent of our hypotenuse, right? So in here, we're going to have secant equals to hypotenuse over adjacent. So let me write in here, secant of theta is 2, meaning 2 over 1, and it equals to hypotenuse over adjacent. How does that help? We're going to label them first. Hypotenuse in here is 2, and adjacent in here is 1. Okay, so if you do the a squared plus b squared equal to c squared thingy, the Pythagorean theorem, you will have this one called like b squared if you want to. It equals to the square root of 2 squared minus 1 squared. And it is negative square root of 3. How do I know it's negative or positive? Because on the downside of the y-axis, this one in here, that's why your answer must be in negative. Okay? So now, how can we find the value of sine theta and cosine theta? Psi theta, it equals to opposite over hypotenuse. So we have opposite, which is square root of negative square root of 3 over 2. And then for cosine theta, I'm running out of space, so let me just come up here and write cosine of theta. It equals to adjacent over hypotenuse, so we're going to have 1 over 2. Okay, so then let me circle the values of psi theta and cosine theta in here and here. So according to the formula right here, we know that psi of 2 theta equals to 2 psi theta times cosine of theta, right? So with that saying, we're going to have 2 times negative square root of 3 of 2, because that is our psi value, times it by 1/2, which is the value of cosine theta right here. So the 2's in here, and in here we can cancel any 2's that we want to. And in here we're going to end up having negative square root of 3 over 2. That is our final answer. Okay. On the key in here, I also show you guys another way to do it. So as you guys can see, this one is one of the Pythagorean identity in different form, right? We know that psi squared plus cos squared equals to 1. So then psi squared, it is 1 minus cos squared. And if I want, I can solve for the value of psi by taking the square root of both sides. And in this case, psi will take the negative value because we're talking about the fourth quadrant. Okay, and in the fourth quadrant, psi is negative. So let me just put fourth quadrant in here so then we all know the psi is negative in here. Okay, so I want you guys to try this example by yourself at home. So cotangent, just a quick recall in here. Cotangent is a reciprocal of tangent, and tangent, SOHCAHTOA, tangent is opposite divided by adjacent. So cotangent, it should be adjacent divided by opposite. Okay, and then we have cotangent positive, cosine negative. So positive and negative. So make sure you guys can base it up on the Austrian tech calculus rule, and you guys have to specify your quadrant. From there, draw a right triangle, label the size of the triangle, and then you find the value of sine and cosine, and after that plug it back into this formula right here, and then you get your final answer. Okay, moving on to the next topic. What do we have here? We have the last formula for the double angle, which is about tangent. So we did it earlier, but in here, let's just make it formalized. So we have tangent of 2 theta equals to 2 tangent of theta over 1 minus tangent square of theta. This is like one of the formulas I want you guys to memorize. We also derived these 3 formulas. Okay, so they would come in handy to use if you guys memorize them. If you don't, that's fine. Okay. Let's talk about a quick example in here. So I make a typo in here. It should be simplify the following identities, not establish. So if you guys can help me change it to simplify, that would be great. So it should be simplify. Okay. The first question, we have psi of 3 theta, and we have to simplify it. We have to turn it into something else. So my hint is that you can split 3 theta into theta plus 2 theta. If you don't want this order, you can also change it into psi of 2 theta plus theta. It doesn't matter the order for addition, right? So you can put whichever one that you refer first. And after that, we know the sum formula for psi. Psi goes psi cos cosine. So we're going to have psi cos cosine here. And for psi, the psi of psi would remain the same. So we start with the sum. We will end up with a sum in here. And after that, what do? We figure out we know that cosine of 2 theta, it equals to 1 minus 2 psi theta. And again, this one earlier, back to the question, you guys might want to ask me, how do you know which one of the 3 formula for cosine of 2 theta you should use? In here, the problem, we have sine, right? So among the 3 formulas, this formula right here is the only formula that has only sine, right? We have a mixture, which is cos squared minus psi squared. We have the one with cosine, which is 2 cos squared minus 1. And we also have the one with only psi. That is this one, 1 minus 2 psi squared. Okay. And moving on to the expression, we also know that psi of 2 theta equals to 2 psi and then cosine of theta. I put a square in here because we also have another cosine here. That's why we have two cosines. Okay. And after that, according to PEMDAS, whenever we have parentheses, we're going to distribute the thing on the outside into the thing on the inside. So we'll go ahead and multiply psi with 1, which gives us psi of theta. And also we have psi times negative 2 psi squared. That means we're going to have 3 psi's, and that turns out to be negative 2 psi cubed theta. Okay. And again, like among this whole line here, everything is psi except for cosine squared theta, right? So how can we turn cosine squared theta in terms of something with psi? We learned about the Pythagorean identity. We know that psi squared plus cos squared equals to 1. So cos squared of theta, it equals to 1 minus psi squared. Okay. And again in here, since we have parentheses, we're going to go ahead and distribute the whole thing on the outside of the parentheses into 1 and negative psi squared. So 2 psi theta times 1, we're going to have 2 psi theta. 2 psi theta times negative psi squared theta, we will have negative 2 psi cubed theta. And after that, we're going to rewrite psi theta minus 2 psi cubed theta from the above. And now, lastly, we're going to go ahead and combine the like term. So we have psi theta in here with 2 psi theta in here, which makes 3 psi theta. And we also have, let me change the color. We also have negative 2 psi cubed theta minus another 2 psi cubed theta. So in total, we're going to have negative 4 psi cubed theta. Okay, so this is the answer. So as you guys can see, I start with psi. I end up with an expression that only has psi in here. Okay, so just a quick heads up for this example that you guys gonna do to turn in. It has cosine, right? So for your final answer, it should have something with only cosine. Okay. And for another example that I think is useful because I remember I saw it a lot in my high school. So this time they want to give you guys a problem starting with cosine to the fourth of theta. How can we go about it? So the fourth in here, it means square and square again, right? Because we know that 2 times 2 is 4, or like 2 squared is 4, right? So from here, we will write it as cosine square of theta all square. So technically, we're going to have like 2 on the inside and another 2 on the outside. So together is like 2 times 2, which is 4, or like 2 squared, which is 4. Okay, on the inside right here, we know that cos squared of theta, this formula, it equals to 1 plus cosine of 2 theta divided by 2. That's why I told you guys it comes in handy if you guys need it in like establish identities problem or simplifying expression problems. You guys gonna need it a lot. So we're gonna go ahead and replace 1 plus cosine 2 theta divided by 2 in terms of, or in place of cosine squared theta. Okay, and we also have the square on the outside. This one, I'm going to rewrite in here. Okay, so how do we go about it? We're going to split it into 2 parts. On the bottom, the easy part, 2 squared is 4, right? We're done with that, no question. On the top part, it's more complicated than that a little bit. So we will have something like 1 plus cosine 2 theta times another version of 1 plus cosine 2 theta. Okay, so in here we're going to do foiling. We do first, last, inner, and outer. Okay, and after that you combine the like terms. So we can have something like 1 times 1, which is 1 right here. And then for last, we're going to have cosine of 2 theta times cosine of 2 theta, which gives us cosine square of 2 theta. And in the inner and outer, we're going to have like 2 versions of cosine 2 theta. That means we have 2 cosine of 2 theta in here. And again, we know that cosine square of 2 theta, it equals to this formula right here. But notice the relationship between the formula. In here, if you start with a theta, then you will have to double it up, okay? So in here, if we have 2 theta, then we double it up. So instead of having 2 theta, we're going to have 4 theta. Just like the idea of how you have like theta in here, and then you end up having 2 theta in here, okay? And it's going to look weird if we have like a 3-part fraction like this one. It looks really weird. So that means we're going to have to split it out. So we have 1, 2, 3, 4 parts on the top part. So first of all, we're going to do 1 divided by 4. And we also do 2 cosine of 2 theta divided by 4. And after that, this 2 and this 4 are together on the bottom. So that makes an 8. And then we have the 1 on top for this one in here. And for the last part, we will have cosine of 4 theta divided by 8. Okay, so now we're going to go ahead and come out of like terms. 1/4 plus 1/8, it turns out to be 3/8. Okay, and then we can also simplify the 2 and the 4 in here. So that will give us 1/2 cosine of 2 theta. As for the last part, it should stay the same as 1/8 cosine of 4 theta. Okay, so if you notice, the problem is start with cosine, right? And we end up having a bunch of cosines in here. So as you can predict in here, the final answer for this problem that in your turn, it will have some sine there only, okay? So no cosine, no tangent, no nothing else. It just has to be sine, okay? And now let's move on to the next topic, which is the last topic of the day also. So what do we do with this one? We're going to have half angle, okay? So remember the last formula that we have? The one that I told you guys to like learn, but not to memorize? This formula in here, this formula in here, and this formula in here. So we talked about the relationship between the angle on the left hand side and the angle on the right hand side, right? For all 3 of them, technically. So on the left hand side, if you have theta, on the right hand side, you have to double it up. So the first one, psi square of theta, and on the right hand side, we're going to have 2 theta. Similarly, for cosine, we start with theta, we end up having 2 theta. For tangent, we start out having theta, and then we end up having 2 theta on the top and on the bottom, right? So everything is double up, okay? So now, what if we want to narrow it down? What if we want to like cut it in halves? Again, we have that relationship again. So like double of a half, that would be just 1, which is theta, right? If you want to think about the logic of this one, it goes like theta divided by 2 times 2. You're going to get theta. We have the same relationship in here for cosine, and we also have the same thing for tangent. So in here it's going to be theta, and in here it's going to be theta also, okay? So I'm not a big fan of half angle. If anything, I'm going to give you guys these formula in the test and in the quizzes. But make sure you know the logic. Make sure you know what's going on in here, okay? As for the last 2 formulas in here, again, these are just for fun, so you guys don't have to memorize it. But sometimes it comes in like really handy, okay? So just in case you guys might want to memorize it, do it if you want. But based on my experience, you barely have it like in trig class. Okay, so a tip in here that I would like to give you guys, if it's too much, then do substitution. What do I mean by substitution? On the inside of the first problem, you guys notice you're going to have the inverse, -1 in here. And I told you guys, whenever you have that -1 in here, you have to switch it back. You have to invert it inside out like this. So we start by having cosine inverse of -3/5. So now you have to invert inside out, and you're going to have something like theta equals to cosine inverse of -3/5. That's like the quick intro for the substitution. And now you have to invert it. So we have to go from green to blue. Okay, so just swap them. Technically, the value on the inside now is going to be on your right hand side by itself. Okay. So now that we know the inside, the green part in here, it's just theta. So then this whole expression in here, it will become psi square of theta divided by 2. The divided by 2 in here, it comes from the 1/2. Okay, so don't get confused by that. And then we know the formula for psi square of theta divided by 2, which is this one right here in red circle. So we're going to go ahead and write it down here, and then we applied it. So 1 would be just 1. 2 would be just 2. Minus is minus. But then cosine of theta, we just solved for it just now. Cosine of theta equals to negative 3/5. That's why we put it back here. We shove it in the calculator, and then we get the answer as 4/5. Okay. If you guys notice, we can do the same thing over here. So you guys can call this one theta and then invert it inside out. So we will get something like psi theta equals to 5/13. But just a heads up, this is only the psi value, right? In order to use the formula of cosine square in here, you need the value of cosine actually, right? So how can you get the cosine value? Make sure you draw the right triangle and find the third side. And for this one in here, it's going to be on question 1 if you want to keep it simple. And after that, make sure you solve for cosine theta before you plug it back into the formula, okay? So don't blindly plug in 5/13 into this formula because it's not right. 5/13 is only the psi value, not cosine value, okay? As for the last example I want to show you guys. So I want to ask you guys to find exact value of cosine of negative 3/8. If you guys do the math and convert this one back to radian, it's not going to be something pretty. I got, okay, so negative 3 times 180 divided by 8 is going to give you something like negative 67.5 degrees, right? That's not something nice because that's not 30, that's not 60, or that's not even 45. We don't know anything about 67.5. So how do we do it? First of all, let's draw it out. We know that it's negative 67.5 negative, so we're going to go counterclockwise. So we do it like this. And since it's less than 90, so it's going to be on question 4. So it's going to be on question 4 right here. So by the all student tech calculus, cosine is positive on question 4, right? So that's good in there. And now, how can I find it? So we talking about double and half angles, right? And the angles right here, it is 67.5. So in this lesson, degrees in here. So in this lesson, you have two options. You can either double it up or cut it in halves. If you double it up, you're going to get something like 67.5 times 2. That is 135 degrees. If you cut it in halves, so you go 67.5 divided by 2. And then it's going to give you something like 33.75 degrees. Okay, which one looks nicer to you? To me, the first option looks nicer. Why? Because I don't know anything about 0.75 degrees in this class, right? So that doesn't help. But we do know something about 135 degrees, right? At the first class, since it's end up with a 5, we know that it's a part of the 45 families. Okay? So how do we do it? We want to solve for the cosine value of 135, and then we're gonna draw another quadrant, and then we're gonna draw 135. 135 is around like between 90 and 180, so it's around this area in quadrant 2 in here. And cosine in quadrant 2 is negative for cosine, right? Because we have all students at calculus, so in quadrant 2, only psi and cosecant are positive. The rest of them are negative, okay? So we know that cosine of 135 equals to negative cosine 45, and by the chart that I made you guys memorize, cosine 45 is negative, or is square root of 2 divided by 2. Okay, so then we will have cosine of 135 equals to negative for the negative quadrant in here, and square root of 2 over 2 for the value of the 45 family in the chart. Okay, that's why I put negative square root of 2 divided by 2 in here. And as the connection to go from here to here, as you guys can see, 67.5 times 2 gives you 135, right? So 135 in here is actually the double angle of 67.5. That means we're going to go ahead and use this formula in here. Let me put it in blue. So we're going to use this formula right here for this step. Okay, so how does that work? Notice that in here we have a square, but in here we don't. In here we just have cosine of negative pi over 8, right? So how can we get rid of the square in here? We have to do the square root. That's why I have the square root in here. In the formula, I don't have any square root, right? In the formula, it just goes like 1 minus cosine of theta, or 1 plus cosine of theta divided by 2, which is the inside of the thing that we have in here, but it's not the whole thing. We have to take the square root to get rid of the square. Okay, and after that, we just plug in the value that we just find, which is negative square root of 2 over 2, and we shove it into the calculator. We get the final answer, which is square root of 2 minus square root of 2, all divided by 2. Okay, so try yourself with the other question. Sine of 195. So again, you guys can have two options. You guys either have, okay, let me write it up here, 195 in here. If you double it up, 195 times 2, you guys have something like 390. And again, this one is not like a pretty number, so make sure you get the reference angle for it by drawing out a quadrant, and then the size, like the psi of the psi value in here based on the quadrant. Okay, and then the other option you have is 195 divided by 2, which is 97.5 degree, and degrees in here also. And again, I told you guys we don't know anything about like decimal angle in here, so let's cross this one out. So just a heads up, you guys will have to do something with 390. Okay, so give it a try and let me know if you guys need help. Okay, thank you for your listening.